Okay, so let's verify the loop and the junction rule. Okay, so let me start off. This is a circuit. It's a simulator and it's free, and I'm going to show you the address. But I want to show you the two rules that we want to verify and then how we're going to verify it. Okay, so here is the address, to the simulator. If you need it, I'll put it in the link. And I don't know why this does this. So the loop rule says that as I go around a loop in a circuit, if I add up the changes in potential across each element along that loop, I get 0, because the electric field is a conservative force. So if I start and end at the same spot, I can't have a change in energy. So if I don't have a change in energy, I have to have a 0 change in potential. Okay. So the junction, that's the loop rule. So the sum of the voltages around a loop is 0. We're going to show that. Okay. The junction rule says that if I have a place where 2 or more wires meet, the current coming into that junction is equal to the current coming out of that junction. And that just says, what if it wasn't true? What if more charge came in than left? Well, where would all that extra charge go? Okay, it would just stay there and build up charge. I mean, you can have that happen in a capacitor and things like that, but no, wait, you don't. Okay, so you have to have the same amount of charge coming in and out per second, and that's the current. So the current coming into a junction is equal to the current coming out of a junction. Okay, now we're going to go back up to this simulator. I'm pointing, and you can't see where I'm pointing. And we're going to measure this. Okay, so go to the simulator. This is a PhET simulator. It's pretty super awesome. You can build your own circuits. And here I have a very, very simple circuit. Okay, it's a battery and then a resistor. Now, it's not interesting to do it in this case, but I wanted to show you a basic circuit and how to build them. You can see here it's showing the flow of negative charges. We can change that if you want to conventional current, and it shows the conventional current is the flow of positive charge, even though it's actually negative charges flowing. So when we talk about I as a current, sometimes it's easier to write it like this. It doesn't really matter though. The other thing I want to do is change. This is at 10 ohms. Let's just put this up to 20. I don't know why. Let's put it at 40. I don't know why. Let's do it 30. 30. I'm gonna stick at 30. Okay. So now I want to add 2 more resistors. So I'm gonna, in this simulator, just grab these wires over here, and then they kind of click together. And these are 0 resistance wires, but it doesn't matter. Okay. I'm gonna put a resistor right here. And let's make, that one was 30. That one's at 10. Oh, and notice this. As I change the resistance, these color-coded bands on the resistor change too. I mean, that's just great. That's just so great. Okay. It really is. That's good job. Okay, so I have another resistor. That's a 10 ohm. Let's just put a 10 and a 15. So I just clip them in there. If you need to cut something, you just click this and click cut, and it takes it apart. And you can put it back together. And then one more wire. Okay, there is my circuit. Let's see if I can move this a little bit bigger. There. Okay, so I have current coming in. Here's a junction. You see some of the current goes this way and some goes that way. So that's a junction. But let's look at the voltage rule, the loop rule first. I want to start at this point right here, and I want to go this way around this loop and back to that point. I want to measure the voltages. Okay, so fortunately I have a voltmeter right there. It has little probes. So let's just do this the real way and break it into pieces. I'm going to put my negative probe right there, my positive probe right there. So this measures the voltage, the change in potential going from this end of the wire to that end of the wire, and I get 0. No voltage change across that wire. That's fine. I want to move around this loop, and I want to always keep the red probe in the front, so I'm measuring the voltage in the same way. So I'm going to put this right here. 9 volts. Remember that, 9 volts. That's the change in potential across the battery because it's a 9-volt battery, even though it looks like a AAA or AA. And then I can do this wire, 0 volts. So all these wires have 0 volts. I can do it if I want to. 0 volts. 0 volts. Okay, now I'm going across this resistor. I get negative 9 volts. So first of all, you'll notice that I get a negative change in potential. If I'm going in the same direction as the electric current, then I will get a potential drop across the resistor. Okay, so we'll summarize in just a second. Now let's look at this wire, 0, and then this wire, 0, and then let's just try this. Put these two together, 0. So let's summarize. Let's do this loop. I did 0 volts, plus 9 volts, 0 volts, plus 9 volts. Wait, let me start over. 0, plus 9, 0, 0, 0, minus 9, 0, 0. That all adds up to, let me get my calculator here, 0. Actually, there's a phone. But, okay. So that loop rule works. Let's do it again. There's actually 3 loops in this case. I have this loop, I have the big loop going around this whole thing, and then I have this smaller loop here. And it doesn't matter which way you go. I can go clockwise or counterclockwise. Okay. I'm going to start here. At this point, I'm going to go this way around the loop. And let's add up the voltages. Okay. So the first thing I'm going to do is go across this. And you see it's 9 volts, positive 9. It's positive 9 because I'm going against the current. This is like going uphill, right? If you're going uphill, you have a positive change in gravitational potential energy. It's the same thing. I'm going to skip the wires because we already know that those are 0. So now I'm going to go up to this wire. Now I'm going with the current. So it's going to be negative 4.5 volt drop. Oh, I didn't change that voltage. Let's change that, the resistance. Let's do that at 15. This previous loop, it still works. Okay. So now I'm right here. Negative 5.4. Write that down. It's important. And then this one's going to be negative 3.6. So negative 5. So I have 0. Well, all the wires add to 0. Then I have plus 9 minus 5.4. Wait, that was 4. Yeah. And then minus 3.6, and that adds up to 0. So it does indeed work. So the loop rule works. Okay. Let's look at the junction rule. Okay, so I'm going to start off with my junction rule measurer. Oh, this one has, this one's, okay, there's another simulator that has a magic ammeter. This one you actually have to take apart to measure things. So, I don't want to rebuild the circuit. I don't want to redo the video. So I'm just going to proceed. So I would normally show you the current right here and there is the same, but I don't want to do that with this multimeter. So I'm going to show the current coming into this junction. So that means I have to take this apart. And I'm going to pull this down right here. And I'm going to put the ammeter right there. There. And now I have the current coming through this ammeter, and I get, if you can see that, that's 0.66 amps. Remember that. That's important. That's the current going into that junction. Now I'm going to cut this. I'm going to cut this. Now I want to measure this current right here. So I'm going to put this right there. This is good and bad, right? Because you can see how to hook these ammeters up. It is kind of complicated. I get 0.3. So I had 0.66, 0.3. Now I'm going to cut it again. Measuring current is tedious. Oh, that's fine. .36. So I get 0.3 plus 0.36 is 0.66. So the current coming in does indeed equal the current going out. Okay, let's put it back. Because here was a question that I had 2 extreme cases that students asked about. There is another PhET simulator that does have a magic it has a magic ammeter that you just hover over and it tells you, and that's kind of cool. Okay. So the question they asked is, what if you take this resistor out? Does this loop still work? Okay, let's do that. So I'm going to take this, I'm going to cut it right there, I'm going to cut it right there. So now I have this. So now it's like, can you still do that loop? Well, let's just find out. So if I start, right, let's check that wire doesn't have any current across it. I'm going to go around this loop right there. So I get 0 volts. I'm going to go right here. I get 9 volts. Look at that. So even though there's nothing there, I still have a change in potential. That's important. Okay. Then I go to the next wire, 0. And then these wires have 0, so I go to this wire. Now I get negative 5.4. And then I go to this wire, and I get negative 3.6. And then so it does indeed still work. It adds up to 0. Okay. Even though there's no circuit, there's no current in that thing, it still works. It has to work because it's a consequence of the conservation of energy. Okay, so now the other case, let's put this back. What if I remove these resistors but have a wire there? That's what they asked. Okay, so let's cut this, take that one out, cut this, cut that, take that one out. And they're like, oh my gosh, they immediately freak out. Oh my gosh, the battery's on fire. Okay, so you'll notice that the current is super, super high, right? It's super high because the current's so high because the resistance in this wire is essentially 0. So you get huge, huge currents, huge. And those huge currents make things hot, and when things get hot, they burn, so there you go, that's burning. So let's just measure do the loop rule. I'll start in this loop. Now I am going to measure the wires. So I'm going against the current, I get 0 volts. Here I do get 4.82 volts across it. There is a current. It's just super small. 0. Now I'm going to measure these wires. See, now you do have a voltage across that wire. This is not a 0 resistance wire. This is a realistic simulator in some ways. So I do get negative 1.92, and then I'm not going to add these up, but you can see that it's going to work. You add these up. Write these down. Negative 1.59. Negative 1.32. That should add up to 0 voltage. It should still work. Okay. So even if you try to break these things, they still work. That's what's really great about the simulator. If you did this, and theoretically you'd have infinite current and everything would be messed up. But okay, I'm going to stop there. That is your loop rule and your junction rule shown with this simulator. Go play with it. It's pretty awesome. You can change a whole bunch of stuff. You can actually change. I'm not even going to talk about it. Let's just say you can. The end.